Hi, Calculus. It's Mrs. Jurosic again. We're going to go over the 2-3 section in the book today because the 2-2-2-3 packet didn't have quite enough of the 2-3 material in it. So this is a separate handout specifically on the limit laws and then some special trig limits. And when we simplify some of those, we will be using the laws to do that, okay? So I just wanted to go over this quickly. There's good news to all of this. All of these limit laws, you do not have to like memorize them. They're pretty self-explanatory. They're pretty logical. And when you come across problems with the limit laws in them, it's just kind of instinct as to what you're supposed to do. So I'm going to just get to it. At the bottom of that front page, we have, suppose the limit of f of x as we approach 2 is 4. Suppose the limit of g of x as we approach 2 is 5, and the limit of h of x as we approach 2 is 8. Use the limit laws in theorem 2.3, all those above, to compute each limit. So for the first one, it says the limit is x approaches 2 on f of x minus g of x over h of x. Well, you know, it's kind of a combination of the difference law and the quotient law, right? There's two things happening here. So on the top, when you do the difference law, you simply take, when you have the values given to you, you can just subtract the values. So f of x, all right, that would be the 4 minus the 5, and divide it by 8. So negative 1/8 is your answer. So it is that easy, at least for these problems like this. I would suggest pausing maybe, and then, you know, seeing if you've done them right, but I'll just keep going, but you can always pause your video and try them yourself. Okay. So we have 6 times the f of x times the g of x plus h of x. So this 6 is like a constant multiple rule. So this is product, and then this is constant multiple. And then we're just doing the sum law right there. So we're just plugging in the numbers that are given to us as we approach 2. So it's 6 times f of x was the 4, and then the g of x was the 5, and then plus 8. So 6 times 4 times 5 is 120, plus 8, 128. And the last one says limit of g of x cubed as x approaches 2. So as we approach 2, g of x is 5, so that's just 5 cubed equals 125. And that is that. So we will go to using the laws in some more complex problems, I guess, with the trig limits. I'm going to first introduce on the back side of the worksheet. The trig limits up at the top are limits that you should probably have memorized. So I'm going to actually put, sorry about that, everybody. I tried erasing, it didn't turn out so hot. Okay. I'm going to all right, so with sine x over x, as the limit approaches x equals, the limit of sine x over x as x approaches 0 is equal to 1. So we're not going to be proving anything at the moment. We are simply going to look at that in the calculator and just sort of get an idea of how this is working. So if I go to sine x divided by x. When I do zoom 7, okay. If I immediately try to plug in 0 into sine x over x, I'm going to get 0 divided by 0, that indeterminate form. So we already know that if I were to try and do second trace and value at 0, we're going to get a blank. There is no value there. The graph is pretty clear. It looks like it's approaching 1 on either side of 0. To verify, when I'm in the value function, I can just kind of keep going and plugging in numbers. That's why I like value in the calculator. So if I do something on the right side of 0, I approach 1. And remember that e to the negative 5, that's like scientific notation, move your decimal point 5 spaces left. And you'll get 0. In essence, it's getting very close to 0. And then if I go to the left of 0, so negative point 0.0001, and we're still approaching 1. Okay? So that is that first one. And notice that their reciprocal statements are the same values. Okay? So you're not memorizing two different things. You just have to remember that if you take the reciprocal of it, it's still equal to 1. All right. And then as an added note, we will do problems like this as well, which this is built on this, the coefficient in front of x being 1, but if the coefficient is anything other than 1, the limit itself takes on that coefficient. Okay, so that's a good one to keep in mind. If I were to simply take this and throw in, let's say, a 7, so 7x over x, okay, and we look at the graph. Okay, so the regular trig window only goes up to 4. So notice I can't even, I have to stretch out my window a little bit to see this, but my answer should be 7. So if I make my y max just for the time being a 10, let's see. Okay, and I need to be on the left and right side of 0 to make sure that 7 is actually what it is. Second trace value, 0.00001. Yep. Negative 0.00001. Okay, and it is. All right, and then let's go ahead and let's turn that one off. Let's turn that one off. And we will put in 1 minus cosine x divided by x. And graph that one. I should have gone back to zoom 7 for trig window. So I had changed my y. Okay. There we go. So again, if you were to plug 0 in directly, you end up with 0 divided by 0, because cosine of 0 is 1. 1 minus 1 is 0, and then obviously 0 here. So indeterminate form, if I tried to plug in 0, we're not going to get a y. It looks pretty clear by the graph that we're approaching 0. Let's just verify 0.0001. And again, it made scientific notation out of both values, right? So this is implying 0, this one is 0. So they're both zeros in this case. And then if I go on the left side of 0, again, same thing, okay? So, and again, it's reciprocal, results in the same limit, okay? All right, so from here on out on this page, we're not going to use the calculator anymore, okay? To verify or find the limit. We're going to actually now use the special trig limits in combination with the laws to simplify them ourselves. So we're going to start with tan x over x as x approaches 0. So that limit, let's see, we don't have a tangent one, right? But when we took pre-calc, we learned a lot about rewriting things and being able to work problems by using either reciprocals or the quotient identities and all those things. So that's exactly what we want to do here. We want to change tangent into sine over cosine. That still doesn't really help us, but we can keep working the problem like you did with trig identities. We can still keep working what we have. And when you divide, you'll be multiplying by 1 over x. Now, if I do a little bit of manipulating here, and I'm going to apply my laws, the product law here. I'm going to switch some things around because it's a product, so I'm allowed to do this. Let's see what we can do. Well, we know this. This is 1. This we can evaluate. When I plug 0 in here, I get 1, right? So cosine of 0 is 1. All right, let's go to the next one. This one, it is this property, this special trig limit. So the answer is 4. Done. The third one. 1 minus, I didn't do a very good job erasing everybody. I had to do an outtake on this one because my dog started screaming at me. He ruined my video. So I had to erase a little bit and start over. Okay, so for example 3, that's the problem with me having to record everything at home. Things happen, life goes on, right? And so I didn't erase very well. I apologize. Okay. All right, so in something like example 3, it's again not exactly 1 minus cosine x over x, but with trig identities that you worked last year, hopefully your mind is going to, oh, maybe I could factor that. Maybe I could, you know, whatever, but factoring is the way to go on this one. So if I factor the top, you could actually, I take that back. It's not the only thing you could do. Factor or use Pythagorean identity. I'll show both. I just thought about that. So let's start with factoring. 1 minus cosine x 1 plus cosine x over x. All right, so the one that is, you know, the identity is right here. No, the identity, pardon me. The limit is right here, right? The special trig limit. And again, we can use the properties right here. It's a product. And I can evaluate each one of these. So we already know that this right here is equal to 0. And yeah, you could you stop there? I suppose you could, but that's not, you know, you finish out the problem. 0 times anything is 0. But remember that 1 plus cosine of 0 is 1. 1 plus 1 is 2. So this is interesting because let's pause for a second on that one. Since this evaluates to 2, you're taking the limit, right? As x approaches any number of a constant, it's always the constant. So this is the same thing as 0 times, meaning this part, all of this is 2. 0 times 2, still 0. Now, the Pythagorean identity, sine squared x plus cosine squared x equals 1, you did 1 minus cosine squared x is sine squared x. So I could actually rewrite this way also, and work the problem. And then, right, separate the fraction, apply my product law, if you will. Okay. This is 1, but sine of 0 is 0, meaning the limit of 0 as we approach 0 is going to be 0. 1 times 0, 0. Okay, And the last one. So limit of sine squared x over 3x squared as x approaches 0. A couple of things you could start with. You could actually bring the 1/3 out before you even start. But what I'm going to do, just to, I'm thinking we're getting the feel for some of this. I did bring the 1/3 out. Right? So it's like having a 1 up here. So I took 1/3 out, constant multiple rule. You do this a lot with derivatives. You do this a lot with integrals. Sine x over, let's just make it happen. So I'm undoing sine x over x, right? Times your limit as x approaches 0 of another sine x over x. See if I did that right. So what I have is 1/3 times, there's my special trig limit, same special trig limit. Okay. So I like these because they also involve having to understand those limit laws and how they can be applied when you're either undoing to get a limit, right? Or factoring or using an identity or whatever you're doing, but it makes you have to practice using the laws in order to get the answer without your calculator. Okay. All right. So that's it for this video. Okay. I will see you in class.